Okay, so this is example 8b in the velocity versus time graph examples. Now this problem's a little bit harder than what we're up to at the moment, and I'll explain that in a minute. I'll just read the question off to start with. So in this question, a skyrocket accelerates upwards at 5 meters per second squared for 2 seconds, and then free falls under the influence of gravity until it reaches the ground again. So with this problem, because it's asked for until it reaches the ground again, it actually makes it a much harder problem than which was probably intended. What I'll focus on is, instead of reaching the ground again, until it, I'll say, reaches height, which that it started accelerating at, that it stopped accelerating. Because that makes it a much easier problem. For those of you that have done equations of motion and want to have a go at this problem, I'll give you the answer at the end. I just won't go through how to actually go about that solution. So what I will do now is we'll focus on the two different aspects of this. So we have a skyrocket which accelerates upwards at 50 meters per second squared for 2 seconds, and we also have the rocket free falling as well. So in order to work out the velocity, we look at the average acceleration, which is equal to change in velocity over time. So we need to know what the velocity is after 2 seconds. So the change in velocity is going to be equal to the acceleration times the time. So it's equal to 50 times by 2, which is equal to 100 meters per second. And that's our velocity after 2 seconds. Okay, we want to know how long it free falls until it reaches the height that it was at 2 seconds. So basically what's going to happen is we have a rocket, it's going to accelerate through the air, and then it's going to have a speed of 100 meters a second, and then we're going to say that gravity is negative 10 meters per second squared. Okay, just to make it simpler for our maths. Sometimes physicists do that just for, they call it back of the envelope calculations. So we have, it will take 20 seconds, if we assume that acceleration due to gravity is negative 10 meters per second squared, it will take 20 seconds to return to the height at 2 seconds. So that height, and that's because if we have a look at, again, if we rearrange this equation here, if we rearrange that, we can say that t is equal to the change in velocity over a. So that's equal to 200, so negative 200, because we had an initial velocity of 100 meters a second, and when it reaches that height at 2 seconds, it's going to be negative 100 meters a second, and then we have negative 10 here, so the time is 20 seconds there. Alright, so we want to draw in our velocity versus time graph. So v is equal to meters per second, and we're going to have 100 meters a second up here, negative 100 meters per second here, and going to accelerate like this, and this is going to be at time 2, and then we want to have a straight line going down here. So this is at, and just wait for Word to catch up and respond, hopefully. It's been playing up a little bit this morning. There we go. So So we've got time at 22 seconds. So it takes 20 seconds, and then this would have been at time 12 seconds. So this is when our velocity is equal to 0. So when our rocket reaches a maximum height, its velocity will be equal to 0. So it doesn't. So it stops accelerating at this point. It stops accelerating, but it actually continues to go forwards up until 12 seconds. That's when the acceleration due to gravity overcomes the initial velocity, and then it starts to fall backwards. So then it actually starts to fall back from 12 seconds down to 22. And that's what I think the question was initially intending. I'll just get a different colour. So for those of you that want to extend yourself maybe, once you've learned some equations of motion, you can come back to this problem and you can work out that it actually continues just for a tiny bit. Hang on, that didn't work. Let's have a look at. Why is this not working? Word has been playing up. So for those of you that don't want to, you can stop watching this problem now if you are happy with that. Because my colour's not working anyway. Okay, there we go. Great. So it actually just extends a little bit further. It's actually at, and this is not the scale, put it in there. It actually gets to negative 109.5 meters per second, and it takes almost another second. It takes 22.95, so it takes almost another second to reach the ground, and has a final velocity of negative 109.5 meters per second. So if you want to try and get that answer, if you want to try and work that out, then feel free, but there's not the space or the time, and it's not really appropriate at this point to be teaching you how to do that one.